Good morning, everyone. As you come in, go ahead and start checking your work and make sure you do the attendance in the chat. Go ahead and keep checking your work. We're going to get started at about 11:02. So as you're coming in right now, you have about 4 minutes. After today's class, I'm going to hang back. So if you have any questions from yesterday's work, if you got any of these questions wrong and you want to ask about them, you can hang back after class. We're going to try to be about a half hour today.
Okay.
Alrighty, so we're going to go ahead and get started right now. I want to quickly recap a little bit of what we were looking at yesterday. So if we think back to where we were yesterday, we learned specifically about three different types or three different relationships between angles that can help us find some missing angles in a figure. The first one that we learned about yesterday was this situation where two angles, angle A and angle B, let's say, add up to 90 degrees. Does anyone know what word we use to describe two angles adding up to 90 degrees? Go ahead and jump in if you want to share the word.
Complementary?
Complementary is the word. Yes, that is correct. So we have our complementary angles. They're going to add up to 90 degrees. We learned about pairs of angles that add up to 180 degrees. For example, angle C and angle D here. And anyone remember what we call a pair of angles that add up to 180 degrees?
Supplementary.
Supplementary is one word we can use for it. What's the other word we use to describe it?
Linear pair?
A linear pair, absolutely. And I see that happening in the chat. We know that those angles add up to 180 degrees. And then the third word that we learned yesterday to describe a pair of angles that's actually helpful to us is the two angles that are across from each other when lines intersect. We'll call that angle E and angle F. And anyone remember what we call those angles that are across from each other?
Vertical?
Those are called vertical angles, absolutely. And what we know about vertical angles is that they are equal to each other. We did learn one other word yesterday for a type of angle relationship. And that word that we learned for that was adjacent. Adjacent angles are just next to one another, but knowing that two angles are next to each other doesn't actually tell me a whole lot about the value of those angles. So that one is the least helpful of all of the words that we learned yesterday. Hang on, I'm still admitting a couple people. We haven't got to 11:05 yet. Okay, so today we're going to jump in and we're going to learn three more angle pair relationships that we can use to solve some of these problems. And if any of you took a look already at the problem set for today, you're going to see that the problems look a little bit more complex. There's a little bit more going on in the problems. They're going to look a lot more like this today. There's going to be more lines in these pictures. So the first thing that I want to draw your attention to is the fact that there's this little green symbol on these lines. And that little green symbol, being on that line and on the line below it, means that these two lines on my screen right now are parallel to one another. Okay, those lines are parallel. And what we're going to be working on today, what we're going to be learning today, only works when the lines are parallel. If the lines are parallel, nothing we talk about. If the lines are not parallel, then nothing we talk about today will work. Okay, this will only work when the lines are parallel. When two lines are parallel, the angles that are created by these parallel lines and this line that's intersecting it, this has a fancy name. It's called a transversal. A transversal is a line that cuts across a pair of parallel lines. When we cut two parallel lines with a transversal, how many angles did we just create in this picture? Can somebody count up how many angles we've created in this picture with one transversal crossing a pair of parallel lines? How many angles did we create? Go ahead, Lewis.
8.
I see 8 angles as well. There's 1, 2, 3, 4 up top. And there's 1, 2, 3, 4 down below. And there's a total of 8 angles now in this picture. But all of these angles are related to one another using some more geo vocabulary that we're going to learn right now. So we're going to focus on an angle that we're going to call 60 degrees right here. We're going to call that angle 60 degrees. And because these lines are parallel and because we've cut them with the transversal, just using what we learned yesterday, if that angle is 60 degrees right there, then the angle across from it is also going to be 60 degrees. And what word did we learn yesterday that proves those two things are equal to one another?
Vertical?
Those are vertical angles, absolutely. So just right there, Knowing one angle in this picture, I already know another angle. Is there any other angle from this picture that I can determine just based on what we learned yesterday? Are there any other angles? Louis Suazo.
Also the bottom 60s because those are also equal
Those
60.
bottom, so you're talking about like this angle here?
Yeah, those angles are also
Those
pretty.
are also 60, but we're gonna learn that today. Okay, we're gonna learn why those are 60 today. We have some new vocab to learn for why those are also 60. You are absolutely correct. We're just not quite there yet. Just using our 3 words from yesterday, vertical angle, linear pair, and complementary. Is there anything else we can figure out in this picture right now? Albert? I can't hear you. I'm not sure your mic's working. Caden, you want to give it a try?
We could use linear pair to figure out the angle next to 60 degrees from the
Absolutely.
very
This
top.
absolutely. If you think about this, this right here is a straight line that's being cut into 2 pieces. If one
Yeah,
piece
that's
is
it.
60, okay, cool. The other piece is going to be what size, y'all?
120.
A
120.
120, absolutely. So we know that this is 120. And if we know that that is 120, then the angle
Yeah.
across from it is also going to be 120 because it is a vertical angle to it. And in that way, knowing just one angle in this picture, we started with one angle right here, this 60. And because we knew that 60, we knew all the other angles around it. That's not that different than yesterday. What starts to be different is that what we can imagine, given that these 2 lines are parallel and they're headed in the same direction, is that these 4 angles right here could slide down. If I picked them up and slid them this direction, they would land right in that spot. And so those 4 angles on the line below are going to be the same as the 4 angles on the line above. And we call that corresponding angles. Corresponding angles. And the shortcut for angles that we use in geometry sometimes is we draw a little angle and put an S next to it. Angles. Corresponding angles. If this is 60, if this angle up here in the top right corner is 60, then the angle down here that's in the top right corner is also going to be 60 because it's in a corresponding location. And if this angle over here in the top left corner is 120, then the angle that's in the top right corner below is going to be 120. They are in corresponding positions. And if this angle right here is 120, then the angle in its corresponding or same location but lower is going to also be 120. And that last one is going to also be 60. The 4 angles from the top relationship are the same as the 4 angles from the bottom relationship. Those are called corresponding angles. And technically, corresponding angles is enough in all of the situations we're going to be looking at with parallel lines. It's enough to prove that all the angles up top are the same as the angles on the bottom. But we have some other vocab words we're going to learn as well because sometimes we want a shortcut. So I want you to imagine for a moment that I told you that this angle right here was 40 degrees. And I want you to find this angle right here. And I want us to be able to prove what that angle is equal to. First of all, can anyone just looking at that tell me what that angle is going to be? Without thinking too hard. David Arroyo?
40.
It's also going to be 40. We kind of recognize that this is an acute angle. And because all of these things, because these 2 lines are parallel, all the acute angles in this picture are going to be 40. Right? So this one across from it's going to be 40, etc. If we were actually trying to prove that to be the case, we'd probably, based on what you know so far, we'd probably say that if this angle's 40, then the one across from it's also 40 by vertical angles, because we know the definition of vertical angles. And then this 40 is in a corresponding location as this one, and that gives me a 40 down there as well. Okay, that's probably what we would do based on what we know right now. However, we're going to use a shortcut real quick because we have another type of angle relationship that we're going to learn right now called alternate interior angles. Alternate interior angles. Sometimes we abbreviate that as AIA. Okay, and that also, yeah, cool. So AIA here, and according to AIA, angles that are in alternate sides of the transversal and on the interior of the parallel lines are always going to be the same. So this is fancy and it's big, but let's break it down. Alternate means that one of the angles we're looking at is on the left-hand side of the transversal, and one of them is on the right-hand side of the transversal. It's on the alternate side of it, right? So one's on the left and one's on the right. Interior means that it's between the two parallel lines, right? So if these are my parallel lines right here, we're talking about stuff that's between those two lines. Okay, so the two angles that are between those lines, but on opposite sides of our transversal, are always going to be the same. And so if we know this is 40, we know this is 40 simply using alternate interior angles, AIA. It kind of forms this little Z pattern here, and we start to recognize this Z in a lot of figures. When we see that Z, we know those two angles are the same. Those are alternate interior angles. And that's a shortcut. Instead of saying that first I did a vertical angle and then I did a corresponding angle, that took 2 steps to prove it. Alternate interior angles just let us use 1 step to prove it. Okay? Any questions to this point? Abby, it looks like you have a question. Go ahead.
The little parallel sign, does that have to be there to tell us that it's parallel?
Yes.
Like the right angle thing? Okay.
Yes, exactly. That's exactly right. So that symbol is required because we're not going to assume they're parallel unless that symbol is there. Okay, cool. Really good question. Sometimes a picture, Abby, might have more than one set of parallel lines in it. So this is a good moment to show that. What if there was another line going like this, and now there's 2 sets of parallel lines, and the symbol we would use is the same symbol, but now it has 2 marks? Because we want to show that these 2 lines are parallel right there, those 2, but we don't want to say that they're parallel to these 2 because they're clearly not all parallel to each other. Does that make sense? If there was a 3rd set of lines in there, we'd do the little arrow symbol with 3 little arrows on it to prove that those lines were parallel. Cool? All right, so I'm going to back that up real quick. Back to my alternate interior angles. Are there any other alternate interior angles in this question? There are. This is 140 degrees. I know it's 140 because it's a linear pair. And this is 140 degrees. That's a different pair of alternate interior angles. You can see the little Z shape that we make looks more like that on there. Okay, those are alternate interior angles. So the 2 new words we've learned so far today, corresponding angles and alternate interior angles. The last new word we're going to learn today is AEA. Anyone think they might know what that stands for, AEA? Go ahead, Lewis, give it a try.
Alternate exterior angles.
Yep, alternate exterior angles, and these are exterior to the parallel lines. These are going to be outside of the parallel line. So for example, this angle right here that I just colored in with a red dot, its alternate exterior angle is going to be an angle that's on the other side of the transversal and outside, and that's going to be down here. Those are alternate exterior angles. If this was 50 degrees, then this one down here would also be 50 degrees by alternate exterior angles. And this angle right here that I've put a star on is an alternate exterior angle with that angle that I've put a star on. In this case, they would both be 130 degrees. And that's our new information for right now. I see a question, Albert. Go ahead.
I'm still a bit confused on how you get the 130 degrees.
Because this is a straight line right here. And what is
Oh, okay. I get it now.
You with me?
Yeah.
So if I just almost imagine like the rest of the picture was not here, and I ran into a question yesterday that looked like that, we would have pretty quickly been able to figure out that we have to do 180 minus 50, right? Right, awesome, good acknowledgement, that was good. So the rest of the picture is here, and because the rest of the picture is here, it's not going to change the fact that these two angles are still related in the same way that we learned about yesterday. So before I move forward, I want to know if there's any questions. Are there any questions on any of those three words? I know that's a lot, right? Like, it's a big shift in our mindset. All of a sudden, we started to look at lines and pictures and shapes and angles. All of a sudden, yesterday, that started happening. And we're going to quickly see that geometry is quite different than algebra. In fact, well, it's quite different than algebra. We're going to still use some of our algebra skills, but there's a little bit more of an element of like a puzzle in geometry, right? And so algebra is very straightforward and step by step. We can follow a set of procedures in algebra. Geometry is going to be a little different because we can all see this in a little bit of a different way. We can all solve each question in a little bit of a different way, but we just need to be able to use our proofs to do it. So as I look at this question right here, for example, and this is going to be an interesting example. Let's see how it goes. If I were to tell you that this angle right here was 50 degrees, and I wanted to know what this was down here, we might all come to the conclusion that that's 50 degrees in a completely different way. So somebody who's really good with their vocab words might say, that's 50 degrees because it's AEA. It's an alternate exterior angle. I'm done. I proved it. It's an AEA. AEAs are always equal. But somebody else might say, well, I think it's 50 because the angle across from 50 is also 50. That's a vertical angle. And then this angle and this angle are corresponding. Well, that proves it's 50, and they're also correct. Somebody else might prove it by saying, well, I know the angle below it is 130. And then I know the other angle below is 130. And then I subtracted from 180 and got 50. That's also true. So there's a lot of different ways that we can approach these puzzles in geometry. And that's kind of the challenge. The challenge really is about seeing the puzzle and working your way through using the vocabulary words that we've learned. And so if we don't know those vocab words, or if we're not comfortable using them, that can sometimes be the biggest challenge when we're doing these kinds of problems. All right, so my goal for today is to actually work through just about all of the practice that was posted. If at some point you are moving faster than I am and you just think that you're ready to go off on your own and fly like a bird, go for it. But that's what I'm going to continue to do for the next 10 or 15 minutes, is just work through the practice problems for today and use that as some more examples. And so this is the easiest set of problems from the practice that was given for today. And we're going to start there. They're called baby proofs, right? And so the whole purpose of a proof is we have to be able to justify or prove what we're saying is the case. Okay, so we're going to have to rely a little bit on our vocabulary words. So as we look at this first question, it's given us that angle A and angle B are parallel to one another. That's the symbol for parallel, two lines right next to each other. And that means that we can go ahead and draw the little arrow symbols on this picture even though they're not there. It tells us that the measure of angle 1 is 103 degrees. And it's asking us for the measure of angle 2. And so right here, we're seeing the exact kind of question that we just looked at a moment ago. We might all have different reasons for how we get to angle 2, but we need to make sure that we have reasons. So what's the simplest way to get from angle 1 to angle 2? Any thoughts, Caleb? Remember, you have
AEA.
AEA, it's an alternate exterior angle. So I can immediately say angle 2 is equal to 103 degrees. And how do we know that? By alternate exterior angles. Is this statement in the proof box correct here? Look what it says. It wants us to prove that measure of angle 2 is 77. Is that true?
No.
No. So we're going to cross that out and we're going to make this our statement. Angle 2 is equal to 103 degrees by alternate exterior angles. We have to have our reason there. All right, moving to the next one. We're told that the lines are parallel, so we can go ahead and put our parallel symbols in there. We're told that angle 3 is equal to 64 degrees, and they want us to prove that measure of angle 4 is also 64 degrees. How can we prove that the measure of angle 4 is 64 degrees? What evidence can we use? What word can we use as our justification? Go ahead, Caden.
We could say it's a corresponding angle.
Absolutely. Angle 4 equals 64 degrees because corresponding angles. Corresponding angles are always equal to one another. Okay, looking at number 3. We're given that those lines A and B are parallel again, so we can go ahead and put our symbols in there. We know they're parallel. The measure of angle 5 is 112 degrees, and we want to know the measure of angle 6. How might we do that? Are
By
5
subtracting 112 from 180.
Okay, why are we able to do that? So you're absolutely right. That's correct. But why are we able to do that?
Because both
Go ahead.
angles need to add up to 180.
Why? Yes, they do have to add up to 180. You're absolutely correct. There's still a why.
It's a straight line.
It is a straight line, but look where the straight line is, Abby. The straight line has this angle 112 on it, and this is the other angle that goes with it. But that's not the angle that we're looking for with angle 6.
Oh,
And then on the other side, we have a measure angle 6, question mark, and we have these things we don't know, right? Those are on two separate lines. So to get you started here, and I'm actually give you a minute to think about this, we can't do this in one step. You're going to need 2 steps to solve this. So I want you to think about what those 2 steps might be. Take a minute right now to think about what 2 steps we could use and what 2 vocab words we could use to prove that. And there's more than one right answer. Give that some thought. If you're having, if you need to use an angle that's not angle 5 or angle 6, just put a variable in that angle so you have something to call it. Right, so in my explanation, I'm going to use this angle right here, and I'm going to call it angle W. Okay, so I'm going to offer up how I saw this, and then I'd love for someone to share if they saw this in a different way. The way that my eyes saw this was that W has to be 68 because it's a linear pair. Right, so W, this angle I call W is right next to the 5. It's a linear pair. It has to be 68. And then angle 6 has to be equal to 68 because it's corresponding with W. Right, so I saw this as first I needed this angle, and once I knew this angle, those 2 angles are corresponding. They're sitting in the same general location. Did anyone see that in a different way? Anyone want to share a different pattern that they saw?
Mr. Can I go?
Yeah, go ahead. Did you
Okay,
use a
so
second angle?
yes,
Which angle did you use and what did you call it?
I used the one on the other side of 6, and I called it angle 7.
Okay, so you called this one angle 7.
Mm-hmm.
Okay.
So the corresponding angle of 5, which is 122, would be 7, which is also 120.
Okay, so
What?
angle 7 is also equal to 112 degrees because of corresponding, like you said.
Mm-hmm.
And that allows me to put a 112 over here. Yep, go ahead.
Okay, and then you subtract that by 180.
And what do we call that? Subtracting by 180. What are those two? What do these two angles have as their relationship?
Vertical. I forgot the word.
They're not
Vertical.
vertical. Can someone jump in and help him with these two angles? Why are these two angles adding up to 180? What word do we use?
Linear?
Linear. It's a linear pair. Okay. There are so many different ways we could have done this. Those are two examples, but somebody else might have said, I know that this angle is alternate interior with that one. And once they found that one, they could have subtracted from 180 to get the 6. Right? There's a lot of different ways we could have done this, but it definitely required 2 steps. Okay. Looking at number 4 now, A and B are parallel again, so we can add our parallel symbols. The measure of angle 7 is 93. And we're trying to figure out the measure of angle 9 here. The measure of angle 9. How might we do that? Go ahead and take a minute. We're looking for 2 steps again here. All right, so my brain, again, my brain tends to see corresponding angles more than alternate interiors and alternate exteriors. So my brain said, if this is 93, then this angle right here is also 93 because it's in a corresponding location. And once I have filled that angle in as 93, then these two angles, 93 degrees and angle 9, form a 180. And that means that angle 9 has to be equal to 87 degrees. Okay, so my first step that I chose was I did corresponding angles first, and then I did a linear pair. Okay, your brain did not have to see it that way. You could have seen it as alternate exterior angles and then a linear pair. You could have seen it as a linear pair and then an alternate interior angle. There's a lot of different ways your brain could have seen that. As long as we can get to that answer and prove it, we're doing all right. What questions do you have at this point? Because we're going to jump a little bit forward here into a picture that's just slightly more dense. Abby, question?
I don't really understand how you did number 3 and 4.
Mm-hmm. So
Like,
3 and
just don't
go ahead.
understand. I
Okay,
don't
so
understand.
3 and 4, we need to take multiple steps. So there's no way for me from this right here, which is 112. Nothing that I learned about on these previous 3 pages talked about how to figure out an angle that's sitting right next to it, but not part of the same line. So
Yeah.
I can tell that this angle right here is 112, and that's using old information that we got last week, right? We called that, not last week, yesterday. We called those vertical angles, right? I can tell that this is 112 because of a new word we learned today called alternate interior angles. I can tell that this is 112 because of a new word we learned today that was called corresponding angles. Those are all things that I can tell. But I can't tell what angle 6 is right away. I have to do one of those things first. And then I can subtract from 180 to figure out what angle 6 is. And that's why it took 2 steps.
Okay.
Okay, we don't have a direct relationship between those 2 angles that we've learned about. There is one, but we haven't learned about them.
Okay.
Okay, same thing happened on the next one. This angle and this angle do not have a direct relationship that we've learned about. We have learned that this angle is connected to this angle though by corresponding. So that's what I did first. And then these 2 angles have a relationship because they have to add up to 180. It took 2 steps to get there.
Okay.
Okay.
Yeah. Okay. Mhm.
All right. So we're going to jump down. I'm going to ask you to take a minute to try to do this. I want to know what every other angle in this picture is. The easiest way for you to do this is to just quickly sketch it. I'm giving you one angle and I want to know whatever every other angle in this picture is. Should take you about a minute, I think. You got this. I'm going to have you go ahead and just put your blue hand up when you know what the other angles in this picture are equal to. And when we get more than halfway, we'll jump in and move forward so we can get to the next question. Okay, that's about half of us. So let's take a look at this question. What we were given on this question was we were given the measure of angle 2 was 75 degrees. That would be great if I got a pen out. Okay. Oh. Okay, there we go. All right, so the measure of angle 2 is 75 degrees. Can somebody tell me another angle that they were able to find based on that, and kind of maybe more importantly, how you know that you got it correct, what vocab word you can use? And there's a lot of hands up right now. So I'm going to ask, if you don't want to volunteer right now, go ahead and drop your hand. But if you're willing to volunteer, leave your hand up. And the hands all disappear. So I have my same 5 or 6 volunteers. There we go. Joaquin, jump in. What's up? Make sure you unmute.
Angle 4 is 75 degrees
How?
because it's vertical to angle 2.
Absolutely. It's vertical to angle 2. It's 75 degrees. Great. Can somebody give me another angle from this picture and how/why they know that to be the case? Adrian, go ahead. Thank you for volunteering.
Angle 6 is the same as angle 2. It's
Okay.
still 75.
Angle 6 is the same as angle 2, 75. How do you know?
Because they're basically the same type of angle, just in different places.
And what word can we use? Do you know the word?
Linear pair?
It's not a linear pair. It's a word we learned today. It's called a corresponding angle.
Oh,
Okay, it's a corresponding angle. So angle 2 and angle 6 are called corresponding angles. We also could have used alternate interior angles now that we had angle 4. Those are alternate interior angles, and that's another reason why they're the same. All right, let me get another volunteer. Oriana, go ahead.
I know angle 8 is the same as angle 6 because of vertical.
Yep, angle 8 is the same as angle 6 because it is a vertical angle. That's all of our 75s here. David Arroyo, can you give us another one?
Angle 1 is 105 because
How do you know?
I subtracted 180 from 75.
Yep, because these two angles, angle 1 and angle 2, are a linear pair. Or angle 1 and angle 4 are a linear pair, right? It's a straight line whether you look at it that way or whether you look at it that way. We still see a straight line either way. So we're going to get a 105 there. I need another angle. Now I have a bunch of volunteers. That's awesome. Let's go to Leslie. Go ahead.
Angle 3 is vertical to angle 1, so it's 105.
Absolutely, it is vertical. Absolutely. Can I hear from Caleb? Go ahead.
7 is 105.
Okay. By what reasoning?
A.
Okay, so it's alternate exterior to this one. They have to be the same. They're alternate exterior.
Mm-hmm.
It's corresponding to that one. It has to be the same. It's a linear pair with this one. It has to be 105. It's a linear pair with that one. It has to be 105. Every word we've learned so far points to that being a 105. And of course, the last one is also 105. And so what we see here in these pictures where we have the parallel lines being crossed by a transversal is there's really only two types of angles in here, the smaller angle and the bigger angle, the acute and the obtuse. And all the acute angles in this picture were the same, 75, and all the obtuse angles were the same, 105. All right, last question I want us to look at, and this has taken a little longer than I anticipated today, so I apologize for that. Our last question here is going to be even a little bit more going on here. There's even a little bit more going on in this picture. Okay, so in this picture, we have two sets of intersecting lines, two sets of parallel lines. And what we can kind of quickly see, I think, and I'm going to use my highlighter for this, is that this angle is going to be the same as this one, and 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 this one. All of those angles are the same in this picture. We've got some vertical angles going across here. We've got some corresponding angles, right? So the way we would have seen this picture previously would have been essentially only seeing this part of it. Now we have two of them lined up. So we have all kinds of corresponding angles. It's a lot of different corresponding angles happening here. So there's also now this other set of all the obtuse angles being the same. This angle and this angle are the same. And this angle, and this angle, and this angle, and this angle. All the obtuse angles are also going to be the same. Okay, so there's a lot going on in this picture. Let me go ahead and draw that back really quickly, just so we have some color coding. I'm going to put these little dots in there for our color coding. So right now, we can already start to tell, without going too far into this picture, that angle 1 is going to be equal to which other angles in this picture? What other angles are going to be equal to angle 1 here? Anybody can jump in.
Angle 2.
angle 2 and angle 3.
Yeah, all these, angle 1, angle 2, and angle 3 are all going to be the same in this picture. Okay. And what's the relationship between angle 1 and angle 4? How are those related? Any thoughts on how angle 1 and angle 4 are related? I see a lot of hands up. I don't know if they're still supposed to be. Go ahead, Arroyo.
They're different sides, but lower.
They're different. Yeah, they're different angles, right? Angle 1 and angle 4 are different angles here. But notice that angle 1 is the same as this one, right?
Yes.
And is there a relationship between these two angles? What do we know about those two angles that are next to each other there?
Linear pair.
They're a linear pair. So we also happen to know that angle 1 plus angle 4 has to equal 180 degrees. It's a linear pair. Okay, so let's start working this out. What we want to figure out by the end of this is what is x equal to and what is y equal to. So we know that the measure of angle 1 is this, and the measure of angle 2 is this. But what do we know about angle 1 and angle 2? What did we already figure out that we know about angle 1 and angle 2?
They're equal.
They're equal to each other. We already said that right here. They have to be equal to each other. So we're going to take the expression for angle 1, 3x plus 15, and we're going to set it equal to the expression for angle 2. And I'm going to give you a moment right now to think about how we solve that equation. Let's go ahead and solve for x. And you should be able to check your work there on the bottom. I went ahead and solved this equation. We should get that x is equal to 20 here. And if x is equal to 20 in this question, what could we do with that 20? How could that 20 be helpful to us? Go ahead, Kinga.
20 would go where all the angles are equal to each other, okay, and where they correspond to each other.
Yeah, so 20 is very important in all of those angles that are equal to each other, but 20 is not the actual angle. Look what it says.
Oh, no, that's x.
That's what x is, right? But we do know that the measure of angle 1 is 3x plus 15. So what could we do with that x that we got?
Would we plug it into the equation?
Absolutely, we could plug it in right there. So what's 3 times 20?
60.
60 plus 15
75.
is 75 degrees. So now I know that
Okay.
measure of angle 1 is 75 degrees. I know that the measure of angle 2 is 75 degrees. And I know that the measure of angle 3 is 75 degrees. The measure of all of those angles is the same. Okay. Was there anything else we needed to find in this question? Was there anything else we were supposed to go looking for in this question?
I know.
Yeah, Adrian, go ahead, Adrian.
Why?
We needed to find y as well. Well, here's what we know about y. The measure of angle 3 is equal to 5 times y. But we now know what the measure of angle 3 is, don't we? What's the measure of angle 3 that we just figured out a minute ago?
75.
75. So Oriana, what could we do with that?
We could plug in 75 equals 5y.
Yep, 75 equals 5y, and let's figure out what y has to be now by dividing. Turns out that y is equal to 15. Okay. So there is one more question posted that I'd like you to give a try to. I want you to try to do it. There's one more question that I didn't include in this group. It's the only thing that we didn't already do together from today's work. Okay, so I want you to give that a try. I will post an answer for that either later today or tomorrow morning for you to take a look at. And then tomorrow you're going to be doing some practice problems It says, it's gonna say it's an Edmodo quiz, but it's not a quiz. It's just a set of practice problems, but I want you to hand them in through Edmodo so I can see how you're doing on this and figure out what we need to do to move forward, okay? So no stress, it's not a quiz. You're just gonna do it on Edmodo. If you have any questions, feel free to hang back. And if not, I hope you have an amazing day. And I won't see you live tomorrow for most of you, unless you need extra help, you can come into tutoring. If not, then I will see you all next week. And I hope you have a great long weekend this weekend. Bye, guys.